In this presentation, we are going to look at spanning trees, and in particular, we are going to look at an example of non-isomorphic spanning trees. So let G be the graph with the following adjacency matrix. I'm going to come back to that in a second when we draw it. Draw this graph G, find all the spanning trees of G, and find how many of the non-isomorphic spanning trees are there. How many non-isomorphic spanning trees does G have? Well, let's draw the spanning tree, or the graph G. So first off, we have A. I'm going to put A here, the vertex A, and that's connected to B, which I'm going to put over here, and we're going to connect them. So that's A finished. B is connected to A, C, and E. Now I'm going to put C down here. And I'm going to put E over here. Now, C is connected to B, D, and E. So I just have to add in an E, a vertex D. I'm going to put that there. And that's connected to that. D is connected to C, so that's sorted. And E is connected to B and C. So there we go. I should have connected C to B already. So that is our graph G. Okay. So what we're going to do now, so that's the graph G, but what we're going to do now is consider the spanning tree. So I'm going to look at each vertex there. We have five vertices, and we'll just see which ones we can sort of remove to form a tree. Now, there are 5 vertices. So the tree must have 4 edges. Okay. Now, this G has 5 edges. So we can remove one of the edges to form a tree. Okay. Now, can we remove this edge, A to B? No, that would disconnect A from the rest of the vertices. So we can't disconnect that one. I'm going to put a cross through that one. Likewise, we can't disconnect that one, but we can disconnect any of the rest. We can disconnect that one, we can remove that one, we can remove that one, and we can remove that one. And in each case, we would get a spanning tree of G. So what I'm going to do now is, that's the graph G again. What we're going to do in the first instance is to remove this one here to get a spanning tree of G. There we go. So we're going to call that tree 1. The reason is I'm going to compare some of the trees later on here, and so we're going to just make a record of the trees and which ones they are. So I'm just going to, let's also make a note of the degree sequence. 1, 2, 3, 1, and 1. Okay, so that's the degree sequence of the tree 1. Let's look at tree 2, where we remove one of the other edges that is connected at B. So we remove the edge that went from B to C, and that's tree 2 there. So let's write out the degree sequence. 1, 2, 2, 2, and 1. Okay. Again, just to be clear, all we've done is remove that one there, that edge that would have been there. And finally, let's go and look at tree 3. So what we've done here is we removed the edge from C to E. And again, let's just look at the degree sequence here. 1, 3, 1, 2, and 1. Now, we can't remove any more edges, so we've actually got all of the spanning trees of G, tree 1, tree 2, and tree 3. So, what we have to do now is consider, are any of those two graphs isomorphic? Now, just remember the degree sequence of 1 and 3, that they're both the same. Tree 1 had this degree sequence also, and 3, 2, 1, 1, 1 was the degree sequence of this. And that was the degree sequence of tree 1 as well. That was the degree sequence of tree 1. So what we're going to do is check if tree 1 and tree 3 are isomorphic. So we have them together here. This is tree 1 on this side. And this is tree 3. Now, so what we're going to do is try and see is there any connection between the two. So this is degree 3 down here, C, and this is degree 3 here. So I'm going to sort of connect them, so to speak. Now, they are connected to a degree 1, a degree 1, and a degree 2. Does that happen here? It does. There's degree 2 here, degree 1 here, and degree 1 here. And the one that is of degree 2, what's it connected to? Well, in both cases, they're connected to an edge of degree 3 and an edge of, vertex of degree 3 and a vertex of degree 1. So these two trees are isomorphic. Okay, and in that case, so we've only got two non-isomorphic spanning trees of G. So there are three distinct spanning trees of the given graph, each made possible by removing an edge from the cycle of length 3 in G. Okay. However, two of these are isomorphic, leaving just two non-isomorphic spanning trees of G. And that is our presentation.